Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine asking an AI a simple question: who was the 10th king of Nepal? The AI actually knows the answer inside its parameters, but somehow it fails to recall it. Now, here's the strange part. If we ask the AI to think step by step first, even when the question is simple, suddenly it remembers. Why does reasoning help memory? That's exactly the mystery explored in the paper. Thinking to recall how reasoning unlocks parametric knowledge in LLMs. Large language models are known to benefit from reasoning for tasks like math, coding, multi-step questions. But this paper asks something surprising. Why does reasoning help with simple factual questions that don't require reasoning at all? To investigate this, researchers tested models with reasoning ON and OFF, and the results were shocking. When reasoning is enabled, models retrieve many more correct answers. The researchers measured this using a metric called pass at k. Instead of checking only the first answer, pass at k asks, if the model tries multiple times, does it eventually produce the correct answer? And the results showed something fascinating. Reasoning expands the model's knowledge boundary. In other words, the model already knows the answer internally, but reasoning helps it unlock that knowledge. The first explanation is called the computational buffer effect. Think of reasoning tokens as a scratchpad. When the model generates reasoning steps, it gets extra compute time to refine its prediction. To test this idea, the researchers did something clever. They replaced the reasoning with meaningless filler text like, let me think, let me think, let me think. Surprisingly, even this nonsense reasoning improved performance. Why? Because the extra tokens give the model more internal computation time. But there's a catch. Too many tokens actually hurt performance. So compute helps, but it isn't the whole story. The second mechanism is much more interesting. It's called factual priming. Instead of logical steps, reasoning traces often contain related facts. For example, when asked who was the 10th king of Nepal, the model might recall the first king, the second king, the third king, and so on. These related facts create a semantic bridge that helps the model reach the correct answer. This is similar to human memory. When you try to remember something, your brain activates related concepts first. Researchers even extracted those facts and fed them back into the model as context. And guess what? The model still found the correct answer without reasoning enabled. That proves the facts themselves are helping the recall. But this mechanism comes with a serious risk. Because the facts are generated by the model itself, some of them can be hallucinated. The researchers built a large pipeline to verify each intermediate fact using search, and they discovered a clear pattern. If the reasoning trace contains false facts, the final answer is much more likely to be wrong. For example, clean reasoning traces produce correct answers about 41% of the time, but traces containing hallucinated facts drop to 26% accuracy. So reasoning can both unlock knowledge and amplify errors. Finally, the researchers used these insights to improve model accuracy. Instead of trusting every reasoning trace, they prioritize traces that contain factual statements, avoid hallucinated facts. This simple selection strategy improved accuracy by 8 to 12% on simple QA, to 5% on entity questions. This suggests a powerful future direction. Training AI systems to prefer factually grounded reasoning paths. So the takeaway is surprisingly deep. Reasoning in LLMs isn't just about solving complex problems. It also acts like a computational scratchpad, a memory retrieval mechanism, helping models surface knowledge they already possess, and understanding this behavior could lead to more accurate, more reliable, and smarter AI systems. But it also raises a fascinating question. If reasoning can unlock hidden knowledge in AI, what else might be hidden inside these models? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.